And with that, I think we can go over to our first talk. Simon Bennetts is project lead at OWASP Zed and is a distinguished engineer at StackHawk, a company that uses Zed to help users fix application security bugs before they hit production. He's talked about and demonstrated Zed all over the world, including Java 1, FOSDEM, OWASP AppSec, all editions, so EU, USA, and Asia Pacific. And prior to making the move into security, he was a developer for 25 years and strongly believes that you cannot build secure web applications without knowing how to attack them. And on that last thing, I couldn't agree more. And of course, many people don't know how to attack them, and that's why we have so many problems today. So I'm really looking forward to Simon's talk. And with that, I'll hand over the mic to you, Simon. Great to have you here.
Thank you very much, Matthew. Hopefully you can see me and hear me okay.
Yeah.
Great. I will now share my screen.
Yeah, that looks good.
Great. Okay, so as Matthew said, my name's Simon Bennetts, and I've actually got a confession to make. I don't consider myself as a fuzzing expert, unlike the rest of the speakers on this in this conference. So why am I here? Well, I'm the project leader for the OWASP Zed Attack Proxy. So hopefully I know a little bit about attacking web applications. And that's why I'm going to be talking about why fuzzing web applications is hard. I'm also on the Open Source Security Foundation Security Tools Working Group, and as I mentioned, also work at StackHawk. So I'm going to start off with what Zap is, because that's my claim to fame, really, and I guess the only reason I've been invited here. And so Zap is a tool for finding vulnerabilities in web applications. Like all OWASP tools, it's completely free and open source. And we're saying it is the world's most frequently used web application scanner, or DAS tool. This is a claim we've made many times. No one's challenged it, so it must be true. But I think now is a good time to talk about terminology, because terminology when it comes to security tools is actually a bit tricky. And this is something we're starting to look at as part of the OpenSSF Security Tools Working Group. And it's something I kind of looked up for this talk as well, because there's a difference. I think there's a difference between DAST and fuzzing, and it's not something that I haven't really found good definitions of any of these things. And I must admit, I tend to describe Zap as a web application scanner rather than DAST tool. But I think there's a lot of terminology out there, and a lot of them are kind of marketing led. So let's first of all start at what is the difference between fuzzing, or differences and similarities fuzzing and DAST. And this is going to be really high level, so apologies to the people on this call, and particularly people on the giving talks about this stuff who know a lot more about this than I'm covering here, or that I do. So I think that the big similarity is they both attack running systems. So it's it's not the same static source code analysis where we're looking at the source code. We actually have to have something running, something we can really attack. But fuzzing is really, we do a lot of attacks as part of fuzzing. I've said random. I mean, there's people who know about the stuff will know there's a lot more to it than that, and it's not really random. There's mutations, all sorts of fun things. But at a high level, fuzzing really is about, at a very simplistic point of view, is sending lots of attacks. Whereas in DAST and web scanning, we actually don't try and do that. We try and do very highly targeted attacks. So we don't try and throw loads of things at an application, which kind of surprises some people. So why do we do that? Why do we not try and do as many attacks as we possibly can? And that brings us on to the first of the problems that we have. And I should mention that in Zap, we do support fuzzing, but we treat it as a manual process. So it's something's it's automated. You can automate it with Zap, but you have to control it manually. And this doesn't really fit in with the kind of the traditional view of fuzzing, which is completely automated. But there are problems with fuzzing web applications, which is the subject of this talk. So, and The first of these problems, the really big one, which is why DAS tools don't make loads and loads of requests, is time. Time is the enemy of DAS tools. So in ZAP, we do passive scanning, and passive scanning is where you kind of look at the requests and responses and just see potential problems based on those. And then we have active scanning, and this is where we're doing the attacking, the kind of equivalent to fuzzing. But we have different rules, and we have different rules for different types of attacks. So we'll have rules for cross-site scripting, SQL injection, all these things. But with ZAP, you can have different strengths for every single rule, every single active rule, that is. And the strengths really come down to the number of attacks we make per parameter per page. So we have a low strength, which is roughly usually around 6 requests per parameter per page. Medium strength, which is around 12. High strength, which is around 24. And then we do have an insane level, which could be hundreds of attacks. And we don't recommend this for automated scanning. Now, these numbers are actually going to seem really low to anyone who's been involved in fuzzing. It's a tiny number of requests. And what we're trying to do is we're trying to get the most bang for buck. We're trying to find as much as we can, but with as few requests as possible. Why do we do that? Well, let's have a look at an example site, an example application we might want to attack. In this case, we've got 100 pages. We've got an average of 5 parameters per page. So that means we have 500 individual targets that we need to attack. And DAS tools like ZAP, we attack up 1 parameter at a time. So we have about 20 core or release quality active scan rules, and medium strength is the default. So we're talking around 12 requests per scan rule. So we're looking at, we've got 500 targets, 20 rules, 12 requests for each one. So 120,000 requests to attack this application. This means we're talking about 20 minutes if your application is responding at something like 100 requests a second. And if you can get only 10 requests a second out of your application, then it's 3.3 hours. Now, these kind of responses, requests per second, might look very low to some of you. You know, surely modern websites can handle thousands of requests a second. But you've got to remember we're talking about web applications here. So we're not talking about static pages, which are just returning content. We're typically talking about, you know, if we're attacking something interesting, then there's probably going to be a database behind it or other web services. So a lot of interactions will be going on. So 100 requests per second is actually pretty good. You know, I think within web applications, we often see 10 requests a second or much less. And in fact, there's many cases where we've actually taken out web applications just by pointing ZAP at them. So these figures are not that unreasonable. So, 20 minutes or a few hours doesn't sound too bad, but you've got to consider other things. We have both alpha and beta quality scan rules, and there are about 20 beta quality scan rules. Then headers. And so when you're attacking parameters, we're typically talking about URL and form-based parameters, but you can often find vulnerabilities in headers as well. So you've got to think about attacking headers and then path elements. So URL path elements, you can often attack individual ones of those to find vulnerabilities too. So this suddenly starts increasing the number of things you've got to attack. And then, of course, you've got things like high attack strength. So what happens if we ramp things up a little bit? In this case, I'm going to say we've got 20 pages in our example site, 5 parameters again, but 5 headers, 4 path elements. So we've kind of got 14 elements per page. So 2,800 parameter targets. We've got 20 core or release quality scan rules and the 40 beta ones and high strength. We're now up to over 4 million requests. And that means if you're getting 100 requests a second response time, that's 11.2 hours, or it's only 10 requests per second, we're talking of, nearly 5 days. And all of a sudden, this becomes a big problem. People won't want to use web application scanners or DAS tools if they take this length of time. People want results that they want really quickly. Now with ZAP, we provide a lot of customization, but in the end, it all comes down to the number of requests and how long they can be processed. So that is our, one of the biggest problems we have when attacking web applications, and this will apply to fuzzers as well. So what can we do about this? Well, you make fewer requests, and that is kind of what we're doing with DAST tools. So when we have medium attack strength rather than high, we're making fewer requests, and when we get to low rather than medium, we make fewer requests. And DAST tools try to do much more intelligent attacking. So we're trying to be a bit more like a manual pen tester rather than throwing loads and loads of data and different payloads at a web application. You can also do so, and that's the targeted request as well. So making sure you actually try and be more intelligent about these things. You can also understand the application structure better, and that's something I'll cover in a future slide. And obviously, speeding up your target system. If you get your target system running on a bigger box with more memory, so it responds quicker, then your scan times will improve. And you can live with it. You can accept, okay, if you want to attack an application a certain way, it'll take a certain amount of time. And I mention this here because it doesn't actually apply to quite a few of the other problems I'm going to cover. You just can't live with many of these. So let's move on, because that's not the only problem we have. Another big problem with web applications is discoverability. So when you're fuzzing functions or things, you typically have definitions available via the language. SAST, source code analysis, has access to all of the code. With web applications, we typically don't have those kind of definitions. We don't have a definition of the entire attack surface area. API definitions do exist, and they're great, but they're not always available. Unit tests are great, but they often don't exist when they're not complete. And with unit tests, what you can do, you can proxy those through your scanner, your DAST tool. We have crawlers and spiders, which can help, but these have limitations. So in ZAP, we have two different spiders. We have a traditional spider, which just looks at the HTML responses, finds links, and follows them. So it's a traditional crawler, and it's very fast, and it's very effective, but it doesn't work well with modern web applications. So modern web applications where the URLs, where the links are generated by JavaScript, you don't get those URLs in the HTML. So the traditional spider doesn't work very well with those, which is why we have the Ajax spider, and the Ajax spider launches browsers and clicks on elements. This can cope with modern web applications, but it is significantly slower. If you think we've got to actually launch a browser, we've got to wait for that page to render, we then go and click on something, got to wait to see what happens. It is much slower than the traditional spider. So solutions for discoverability. API definitions are obviously great for APIs. Sitemaps, if you can generate those from your application, they will definitely help. Comprehensive unit tests are really great, and they will help with the next problem as well. And using standard HTML controls so that crawlers can actually explore your application well. If you make your application hard for automated tools to explore, then you will be shooting yourself in the foot when it comes to security tools. So the next problem is good test data, and this kind of ties in with the discoverability. So if you imagine a register user form, so if you're a manual tester, whether QA or penetration tester, you come across this form and you'll fill it in. And a scanner like ZAP will discover the form and will fill it in as well. And then you get an error message saying username must be an email address. Now, as a human, it's very easy to go, okay, right, I will now put test.test.com in. That's quite straightforward. That is much harder for an automated tool. Actually finding out where that there is an error message, there's been any problem, parsing it, those things are just impractical. So an automated tool would typically not be able to fill this form in, and therefore it won't successfully create a user, and it won't open up a whole set of other functionality that could be available in the application once you've done that. That means that because you haven't filled in this form effectively, that means your automated tool will not be able to attack all that functionality. So solutions, as I said before, comprehensive unit tests. Unit tests are a great way of essentially teaching web security tools how the application is expected to be driven, and it allows the application to discover more content. Adding the attacks, we can do that. The tool knows all about the attacks. Getting good data which is relevant to your application is much harder, and unit tests are great for that. Tools like Zap allow you to do manual configuration. So if you know there's a problem and you haven't got unit tests, you can configure Zap to say this particular parameter needs to be an email address or anything else. But again, that's manual configuration. And that's one of the reasons why DAS tools can prove a bit tricky, because you've got to set them up right for every application. Next problem is understanding the web application structure. So DAS tools like Zap build up an internal map of the application. And this is very important because this is how they actually attack the application. And if their map is not accurate, then they won't attack the application as effectively as possible. There are two different problems we can have here. One is that the application map can be too small. And it's TOTOO, I've only just noticed that. I'll have to correct that. So if your application map is too small, then the scanner will miss features. So how can that happen? Well, one reason is if you think about URLs, and a tool like Zap will typically expect that the path elements of a URL will actually represent the site structure, and the URL parameters will actually be data. And so if you have a parameter called page, then that will be typically considered to be data, and we won't attack it in the same way. So if you have things like page equals contact us, page equals login, we will only attack that particular URL with one of those values rather than treating it as a part of the site structure. That means that Zap doesn't understand it, and you'll have far too few pages, and Zap will not attack them all. Then we have a problem where parameters represent different actions. And again, it's a similar thing. So if you've got action equals add, action equals delete, by default, Zap will just attack the first one. It'll say action equals add, it'll attack everything else, and then it'll start attacking the action parameter. It won't attack all the other parameters with action equals add, and then attack all the other parameters with action equals delete, etc. So that's the problem where the application map is too small. Then we have a problem where the application map is too big. And the problem here is the scan will take much longer than it needs to. And this is typically caused by database-driven content. So if you think of those URL paths again, say if you've got company and team, and these aren't the actual elements of these are what is represented in the company in the URL. So we'd have company equals, so we'd have Google, we'd have Microsoft, we'd have StackHawk, all these things in company, and then we'd have a set of teams. And if you have an application like that, then tools like Zap will typically treat these things as separate URLs. And that's a pain because this content is probably coming back from the database. So if you attack these pages with different company names and different team names, you're still actually attacking the same code. So attacking it 10 times, 100 times, 1,000 times, it doesn't make any difference. You're not getting any benefit at all. And of course, you have a problem with discoverability here. Say you have a calendar app. How long does it take to crawl a calendar app? Well, it's essentially infinite. You're not going to run out of years. So, your spidering could never finish if you don't have put some sort of limits on it. So that's the kind of problem with understanding the web application structure. If you don't understand what that structure is, you'll either miss features or the scan will take much too long. Some of the solutions: auto detection is ideal. If your tool can detect these things, great, but that's really non-trivial. Manual configuration is usually the way to go. And again, that means you have to know about your application. You have to know how to configure your tool to handle it. Then authentication. This is a perennial bugbear for anyone who does any automated testing on web applications. There are so many different authentication mechanisms. And it's really hard to tell which one is in use, and even how to tell whether they're authenticated or not. Sometimes you can get, if you're dealing with an API, things might be easier. You might get a sane response code, HTTP response code, or at least some error message you can easily detect in the response. But when it comes to web applications aimed at humans, it's much harder to tell if you're authenticated, particularly if they handle unauthenticated users as well. So it's really hard to know whether you are authenticated and whether you, once you have been authenticated, whether you stop being authenticated. There are no standards around these things. They're all kind of application specific. And a lot of authentication mechanisms have anti-automation features, which of course are going to cause problems for automation tools. And don't get me started on single sign-on. That's just, it's a complete nightmare. It makes life really difficult. So some solutions, authentication tokens. If you can get a token which authenticates your tool and pass it to that, then that's a really good practical option. The other option is like turn off your authentication or turn it down. Say you have an application that needs single sign-on on, but actually you have a configuration where you support simple form-based authentication. In your test environment where you're using your automated tools, use the form-based authentication version. Don't use single sign-on. It makes your life so much easier. Auto detection obviously is the ideal here if you don't have those options, but that proves very hard. And then we're back to manual configuration, which again is manual and is a pain. Then following on from that, we have session handling. Why is this a problem? Because if you don't maintain the session, then you've got to continually re-authenticate. And typically, once you've authenticated, if you try and attack something and you're not maintaining session, you'll be kicked back straight to the authentication page. You won't be able to make any attacks at all. So you actually have to maintain session. Now, this is a bit easier than authentication usually. So cookie-based stuff is fairly well known and fairly well handled, fairly straightforward. Client side can often be trickier. And then you've got a problem with logout links. So, if you're exploring the application or if you're attacking things, if you hit the logout link, then you'll get logged out. And again, you've got to detect that. You've either got to avoid these links, avoid getting kicked off, or you've got to detect it and handle it. But there are also other session invalidating events. And that could be kind of like web application firewalls, or even that kind of web application firewall functionality built into applications. So when I was a web developer, I used to include traps. So traps are hidden fields, which you know the value of. Well, there can be a whole load of things, but in the case, I often put hidden fields in. And if that hidden field got changed, you would know it's an automated tool or somebody playing around with it, and you'd get kicked off. Or you'd start including logging, make more logging and alerts would go off, whatever. But if your application or you have a web application firewall that has these kind of features, then these can invalidate your session and potentially kick you off and not let you back in again. So those are complete pains. Solutions for these: auto detection in the session handling is usually easier, but again, we just come back to manual configuration. And another thing, use standard mechanisms. If you kind of invent your own, then you're just asking for trouble. I could have put this in authentication as well, but I really hope people don't come up with their own authentication mechanisms in this day and age. And then finally, I think we've got issue detection. How do you know if you actually have a problem? So some issues are very visible in the web user interface. You get things like stack traces, reflected XSSs, all these kind of problems which are visible to a user or to an automated tool. Other ones are much harder. So blind SQL, you're kind of looking at timing issues there, out of band issues. So you're attacking remote services effectively, so you don't see any response via the web UI. And DAS tools typically can't see inside an application. So they might be causing all sorts of problems to the application, but if it's not visible via the interface that the DAS tools are actually driving, then you can't tell that it's very difficult to tell that there are real problems. So in this case, solutions, mostly down to the tool. There is some manual configuration as well. So often with error messages, you can put those into tools like Zap. And you can do things like, if you can do server-side detection, looking at logs, that will help. Then there's out-of-band application service testing. So this is where you set up a service that can receive HTTP, DNS, and other protocol queries, and you make attacks, and then you see if that service actually detects it gets hit by pinged by these requests. And there's IAST, interactive app service testing as well. So this is where you're instrumenting the code, and then you can actually see what's going on. And that is going to give you a much better view of your application than just attacking it from the outside. So as a quick summary of all the kind of problems you have with attacking web applications, both via DAS tools and, I'm afraid, via fuzzers as well. If the time problem, it's going to take a long time. Discoverability, if you can't explore an application effectively, then you won't be able to attack all of it. Getting good test data, again, making it easy so you can actually discover more of the application. Understanding the web application structure, building that good map up inside your tool. Authentication, because if you can't authenticate, you can't get to the really juicy stuff. Session handling, because if you don't maintain a session, then you won't be able to attack anything. And finally, issue detection. How do you tell there actually are any real problems? And that's it. So that's everything from me. If you want to learn more about Zap, then we've got a website, www.zedaproxy.org, and you can follow ZA Proxy on Twitter. And you want to learn more about the OpenSSF security tools, then have a look at openssf.org.
Thank you so much, Simon. That was an excellent introduction and a really fascinating insight into all the issues we have in web application security. So we are open to questions. You can join the Slack channel. So there's a link posted in the Click Meeting chat. If you're using the web app, it should just bring you right to the channel. If you're using the desktop app, you can click on the little plus icon next to channels and then type in the name Simon. You will see the channel and can join it there. Yes, I've gotten a number of questions as direct messages, but there was one actually in the channel, so we'll start with that one first, Simon, if I may. Max is asking, should those numbers be multiplied by 3 to 4 to DAST fuzz on Firefox, Chrome, and Safari, or is the goal to find conceptual bugs? And I believe that came up when you were showing all the kind of the numbers, how many requests you can send. Yeah, so they're asking, should these numbers be higher?
Sure, numbers could always be higher. So what we typically with DAS tools, we try and attack directly from the tool, like from Zap. So if we attack via the browser, it takes so much longer. So what we're really doing is we're typically proxying requests through Zap. So either manually proxying via your browser or using the Ajax Spider and proxying those requests through Zap. But we actually do the attacking from Zap. So this means things are much quicker. And we don't tend to do the browser-specific ones. We do have some, but we have much fewer. But if you actually want to explore the application via Chrome and Firefox and Safari, then the whole exploring thing will take longer. And in this particular case, I wasn't even including the exploring time. That was just pure attacking an application we already had 100 known pages for. But yeah, that will definitely increase the time taken to explore.
Okay, and Tar is asking, from Zap, can we do API fuzzing?
Yep, so as I mentioned in the talk, fuzzing, as far as Zap is concerned, is a manual process. So what you can do is you can highlight any part of any request, and then you can specify the payloads that you want to send to that particular target. And you select multiple targets and multiple different requests. You can do sort of pre and post processing, all those things, but it's very much a manual process. So yes, you can do that on any request, whether it's an API one or not. When it comes to actually DAS scanning, then yes, Zap does DAS scanning or web scanning on APIs. We support the OpenAPI Swagger or Swagger definition. We support SOAP and we support GraphQL as well.
Okay.
So we've actually got a Docker image, and we have a package scan which is just focused on API scanning as well.
Okay, so there are lots of questions coming in, so I'm going to try and pick out some. Bennetts is asking, apart from performance, what are the other issues with the Ajax Spider? Is it able to get good coverage on framework-based apps such as React apps?
It depends what features you use. And one thing it's worth pointing out is the Zap core team, we don't get a huge amount of feedback. So you don't have to tell us when you download Zap, you don't have to tell us when you use Zap. We know ZAP is used really heavily all around the world, but we don't actually get a lot of people telling us what they're using it for, what problems they hit. We get some problems reported to us, but it's very difficult for us to know how effective these things are. We don't see the results. So, we know there are some apps where it gets good coverage and some apps where it's not so good. And at the moment, we don't have enough data to tell us, which ones of those are. And, even if we had instrumentation or whatever in ZAP, we still wouldn't know anything about the target application, how effective it is. So we're kind of very reliant on feedback from people, and we don't get enough. So more feedback, please.
Okay, so you have a great audience here who I'm sure will all be trying out and giving you feedback, maybe more than you can cope with. So
we can cope with a lot of feedback, don't worry.
Okay, so then some message questions which came over direct message. What are the most typical and most critical bugs you find?
Well, so there are, tools like ZAP are good at finding particular types of vulnerabilities. So the injection ones, so your cross-site scripting, your SQL injection, those type of things. If you're using ZAP manually, then it's very different. And I think, this is one thing where, just using automated tools is not the solution, particularly with web applications, because with web applications, the really fun ones, when you're attacking the application logic, and that needs a human brain. You need to understand what the application is trying to do and then subvert it some way. So a classic case could be if you've got a shop and you have, you've got a basket and you find out that you can attack, you can change the requests and you can put a negative amount in. So you put -100 of this particular item and all of a sudden the shop owes you money. Now, an automated tool, it can put minus a negative amount in, but it doesn't know that we're talking about a shop. It doesn't know we're talking about money. It doesn't know that we can actually, getting money off the shop is a bad thing. So attacking the logic, you really need to, until we've got really good artificial intelligence, which we don't have, you need that human brain. And tools like ZAP are really great for allowing pen testers to get on to see what's going on, but you need that brain to kind of understand things. So the really fun ones, I think, are the ones you find manually using tools like ZAP. But yeah, the injection ones are kind of classic ones for DAS tools to find automatically.
Okay, actually, there's a follow-up question which leads on very nicely from that. Are the types of bugs you find changing over time, or are they the same bugs coming up again and again?
Feedback. Again, we don't know what bugs ZAP is finding. We would love to know more. So
then
yeah.
let me rephrase the question. Have you had to update ZAP a lot to find new classes of bugs, or are you more kind of improving the ones you already have?
Well, I think modern web applications add a lot of complications because you've got a lot more functionality in the browser, and that makes things much harder as far as traditional security tools are concerned. So that's something we need to improve. Yeah, I think over time, particularly when I was at Mozilla, when we were looking at things like the bug bounty and bugs we were finding, the traditional ones are becoming less. It will depend on the applications and the experience of your developers and whether you're using automated security tools or not. So it's, I don't have that kind of wide view of all the applications that are across a lot of companies. But I think the experience I've had that, developers are learning more about security. We're not seeing some of the simple stuff anymore. It is getting harder for security tools, and that's a good thing.
That's excellent, yeah. Okay, looking at the time, we have time for one last quick question. Thumb asked, can ZAP leverage unit tests in the form of automatic test scripts from Selenium or Appium?
So the best thing to do is proxy those through ZAP. So if you can proxy your unit tests, proxy them through ZAP, that essentially teaches ZAP about your application. It teaches about the structure. It teaches about good, useful test data for exploring things. That's an ideal approach as far as I'm concerned.
Excellent. Well, Simon, thank you so very much for that excellent talk and all your answers. So community, please give Simon feedback on what you're doing with ZAP. And if you want to hear more of that, you can follow him on Twitter at Signon. I hope I'm pronouncing that correctly.
Yeah.
I'll spell it out for you. It's at PSIINON. So PSIINON. You can follow him on Twitter if you want to hear more. Okay, so thank you, Simon.
Thank you very much,
Now let's move on to our next talk.